All right, what's up, everybody? Today we're going to be starting Unit 2. We're going to be talking much more about what atoms look like, what they're made of, how they can be the same or different from one another, and just generally learning a lot more about what's going on inside of atoms that, these atoms that make up our entire universe, right? It's important that we learn what these things are made of, what it looks like, how they behave, so that we can talk about what happens when they interact with each other. So what happens to form a chemical bond, what happens in chemical reactions. We have to have some base information to be able to talk about that stuff in any sort of detail, okay? So today we're going to be talking about isotopes. I'll tell you exactly what that term means, but if you're taking notes at home, this is the title for today's lesson. Okay, the objective for today, we're going to be learning how to determine the number of protons, neutrons, and electrons in an isotope of an element given its name or nuclear symbol. We've already kind of learned how to do this first part here, right? Determining numbers of protons, neutrons, and electrons. The thing is, today we're going to be talking about isotopes, which are different versions of the same element, and we're going to be learning how to get these numbers based on either the isotope's name or its nuclear symbol, okay? And I'll reference this objective again as we get further into the video. Okay, so I wanted to show you guys the first three elements on the periodic table. I've got a nice little drawing of what an atom of that element might look like and some information about it. So this is just to sort of remind us of what we learned at the end of Unit 1 that I'm just reminding you what we need to know moving forward into Unit 2, okay? So we have the first three elements here. This is hydrogen. Hydrogen has an atomic number of 1, and its atomic mass on the periodic table is 1.008. What we learned in the past was that this atomic number tells us two things. It tells us the number of protons, and it tells us the number of electrons. So you can see down there at the bottom of the slide, protons and electrons in an atom of hydrogen are both 1. And that's why, when you look at this model here, when we draw hydrogen, this is what it looks like. 1 proton, 1 electron. This mass number here, what we did previously is we rounded that number to the nearest whole number. In this case, that would just be the number 1. This mass is equal to the number of protons plus the number of neutrons. Okay? And since we already have 1 proton, that means that if our mass is 1, we can't have any neutrons, right? Because 1 plus 0 has to equal 1, right? It's kind of like an algebra equation. 1 plus x is equal to 1. What does that x have to be? Well, if we have 1 proton and our mass is 1, x has to be 0, right? We can't have any neutrons. That is a bit different when we look at our next element here, helium. Helium is atomic number 2. That means it has 2 protons and 2 electrons. Sorry about that thing popping up covering the bottom of the screen. It happens whenever I move my mouse down there. So helium has 2 protons, 2 electrons. The mass is 4.003. Once again, we rounded that number to the nearest whole number. So that would be 4. And so if the mass is 4, then that means there must be 2 neutrons, right? And that makes sense, right? If you look here, this is where the mass is for an atom. It's the protons plus the neutrons, right? So the protons are these positively charged red ones. The neutrons are the green ones that are neutral, right? They don't have a plus or a minus. And so there's a total of 4 here. And if we know that there's 2 protons, that means there must be 2 neutrons in order for there to be an overall mass of 4. Okay, and then lastly, we have our third element here, lithium, atomic number 3. So that means 3 protons, 3 electrons. Its mass is 6.941. If we round that to the nearest whole number, that would be 7, right? 6.9, that would round up to 7. So that means our mass in our nucleus here in the center, the protons plus the neutrons, has to be 7. So if I have 3 protons, that means I must have 4 neutrons, 4 of these yellow neutrons, to make a total mass of 7, okay? So hopefully that's a decent amount of review there for you guys. We learned that in the last lesson of Unit 1. Now what I want to talk about today are these numbers that I've just sort of circled here for you, okay? These mass numbers. What is going on there? Why are they not whole numbers? Why are they numbers with a decimal point and lots of numbers after the decimal point. Like, what's going on there? Well, the reason that these elements don't have masses that are whole numbers, the reason that we have a decimal point here and some decimal places, is because not every atom of hydrogen looks like this. Not every helium atom looks like this. Not every lithium atom looks like this. Some of the atoms of these different elements look a little bit different, and it's their mass that's different. Okay, so we're going to learn about these things called isotopes that have different masses from one another. Okay, so let me show you the definition here. An isotope, or isotopes, are different versions of the same element that contain the same number of protons and electrons, okay, but a different number of neutrons. Okay, so the protons and electrons are still the same amongst these different versions, but each isotope has a different number of neutrons. Okay, and I think it's best to show you this in terms of a visual, right, a picture. So what I've got here are the three different isotopes, or the three different versions of hydrogen. Okay, so hydrogen usually looks like this. Okay, it's got an atomic number of 1, so that means 1 proton, 1 electron, and the mass for this version of hydrogen is just exactly 1, which means no neutrons, right? However, there is some hydrogen out there in the world, in the universe, that does have a neutron, okay, and that looks like this. Okay, we have the 1 proton and 1 electron, right, so it's still got that atomic number of 1, but there's a neutron here, so the mass of this atom would be 2. And then, to make things even more complicated, there is another version of hydrogen that has 1 more neutron than that. So we still have our 1 proton, 1 electron, but this one has 2 neutrons, and this would have a mass of 3. Okay? This is what isotopes are. It's the same element because it has the same number of protons, right? Same atomic number. So it's still the same element. These are all hydrogen. The only thing that's different is the number of neutrons. 0 neutrons, 1 neutron, 2 neutrons. Okay? That's the only difference. And what that difference in neutrons means is that they have a different mass, right? This is a mass of 1, this is a mass of 2, this is a mass of 3. You can see the symbols and the names down here. I'm going to talk about those in more detail in just a second. But as you can see down there at the very bottom, this is called hydrogen 1, this is called hydrogen 2, and this is called hydrogen 3. Okay, so the masses for these different isotopes, like I said, different isotopes or different versions have different number of neutrons, which means a different mass. So the isotope mass is the mass of an individual isotope of an element, right? It's very important that you understand this. Isotope masses are not on the periodic table, okay? So let me go ahead and pull up the periodic table for you really quickly. When you're looking on the periodic table, these numbers here, these mass numbers, are called average atomic masses. They are not actual masses of isotopes. They're the average of all of the different isotopes. That's why they're those really long numbers with all those decimal places, okay? So whenever you're working on an assignment that has to do with isotopes, like today, you are never going to be looking at this number. Okay, this number right here is an average of all the different isotopes. If you're talking about if you're interested in one specific isotope, then you're not going to be using this number. What you're going to be using instead is adding the protons and the neutrons together. Okay, so for example, if we go back here and look at this atom here, this is called hydrogen 3. If I asked you what the mass of this was, it's 3, because it's the number of protons plus the number of neutrons. It is not this number right here, right? So even though the periodic table says that hydrogen has a mass of 1.008, this is an average of all the different isotopes. What this number really means is that the average is very, very close to 1, and that's because this version of hydrogen is so much more common than these two, okay? But this one does exist, and for this specific isotope, its mass is 3, okay? And that comes from, once again, protons plus neutrons. 1 plus 2 is equal to 3, okay? So whenever you're talking about isotope mass, do not look at the periodic table. Instead, you should only be thinking of protons plus neutrons. When we name isotopes, it's very simple. You write the element name, a dash or a hyphen, and then the isotope mass. So here are some examples, right? Hydrogen 1 or helium 4. Back on this screen, down at the very bottom, you can see the names of these 3 different isotopes of hydrogen: hydrogen 1, hydrogen 2, hydrogen 3. Those are the names for those different isotopes. We can also write down a symbol called a nuclear symbol, okay, or an isotope symbol, that is another way to refer to an isotope. It's kind of like the name, it's just written in a different form. You've got the element symbol over here, and then you're going to have 1 or 2 numbers over here. This top number is always going to be there, okay? That's the mass number, right? So this right here would be helium 4, right? So if this was the name, helium 4, this is how you would write it in the symbol. Sometimes you will see this number here as well, the atomic number, but most of the time, actually, this number is not included. Okay, so just kind of in your imagination or with your hand, like cover over that number, right? Normally, an isotope symbol or a nuclear symbol only has the element symbol and the mass number up here on the top. Usually, this atomic number is not included. Okay, so what we are doing today, right? If you think back to what the objective was, I can determine the number of protons, neutrons, and electrons in an isotope based on either its name or its nuclear symbol. How do you do that? Well, I've got a nice little reference slide for you. So while you're working on your assignment for me today, you should have this open on your Chromebook as, like a separate tab. Have this open and reference this while you're working on the assignment, okay? To find the number of protons and electrons, this is exactly the same as it was in Unit 1. Both of these are equal to the atomic number, which means they're equal to each other, okay? So protons and electrons are both equal to the atomic number. This you can find on the periodic table, right? The one place you have to be really, really careful, right, is finding this number of neutrons. To find the number of neutrons, you're going to do the mass minus the protons, but it's the isotope mass. It's not the mass on the periodic table, okay? So just be very careful about that. So you can find the mass either in the symbol or in the name, right? Or if you have the number of neutrons and the number of protons, you can just add the protons and neutrons together to give you the mass, right? So once again, please have this final slide of the notes up while you're working on the assignment for today. This is really going to help, I think. It'll make things much easier for you as you're answering the questions for today. Okay? Thanks for watching, and I'll stick around to help explain your all's assignment as soon as you get done watching this video.